Chapter 3, Section 4, Greatest Common Factor and Common Binomial Factor. In this section, what we're going to do is we're going to talk about factoring, which is undoing what we did in the previous section. In the previous section, we learned how to multiply monomials and polynomials. And this time, what we're going to do is we're going to undo that multiplication, and it's called factoring. So in this section, we're going to talk about 5 different techniques of factoring, and I really would like you to write down these techniques, because when you're taking a test or when you're doing some homework or studying, you need to go to this list and say, okay, I need to factor out the greatest common factor, or I need to group, or I need to use a pattern or something like that. So you need to keep this list in your mind. Alright, so the first one that we're going to talk about is factoring out the greatest common factor. And the reason being is because every time you factor a problem, this would be the first thing that you're going to look for. So if you remember in the previous chapter or the previous section, we talked about distributive property, where you have a monomial factor and you're going to multiply it times everything in the group. So here you would have A times B, which is AB, and then A times C, which is AC. Well, when you factor, you're going to start with this polynomial, and then you're going to see what's in common, and you're going to factor it out and turn it back into a multiplication problem. So to factor out the greatest common factor, you need to be able to recognize the monomial factor that is in common to all terms. So let's look at these 3. This one here on the left, it says 2x to the third plus 4x squared plus 6x. Well, I can see that there is a 2 that will go into each one of those terms. So that's part of the greatest common factor. And I can also see that there is at least one x in common with all 3 of those terms. So once I have the greatest common factor out front, what I'm going to do is I'm going to turn it back into a multiplication problem. So basically, when you factor out a greatest common factor, you're dividing everything by 2x by 2x. So we're going to divide everything by 2x. Alright, so if I divide 2x to the third by 2x, 2's are going to cancel out to 1. One of the x's are going to cancel out, leaving me with an x squared. Plus 4x squared divided by 2x is going to leave me with a 2x. And then plus 6x divided by 2x is going to be 3. So this division we learned how to do earlier in chapter 3, so you should already know how to do that. So again, to factor out the greatest common factor, you're going to look to see what's in common with your coefficients and your variables. So let's look at this one. Between 18, 6, and 24, I know that I can factor out a 6. And as far as the x's are concerned, I have 2 x's here, x squared. I have an x to the first here, and I have an x to the third here. So they have at most one x in common, so I'm going to bring that out. So as far as the y's are concerned, I have y to the third, y to the fourth, and y to the second. So I have at most, each one of these have 2 y's in them. So I can factor out a y squared. So again, if I divide each one of these by 6xy squared, if I divide 18x squared y to the third by 6xy squared, 18 divided by 6 is going to be 3. X squared divided by x is going to be x. And y to the third divided by y to the second is just going to be y. Alright, this middle term, if I divide 6xy to the fourth by 6xy squared, 6 divided by 6 is going to be 1, x divided by x is going to be 1, and then y to the fourth divided by y to the second is just going to be y to the second. And I just don't write the ones, we just don't write those in algebra. Okay, for the last one, 24x to the third y to the second divided by 6x y to the second. 24 divided by 6 is going to be 4. X to the third divided by x is going to be x squared. And y to the second divided by y to the second is just going to be 1. So those are going to cancel out. So there's your answer here. Alright, for the last one. There is a 15 in common with the coefficients. Between 15 and 45, I can divide out of 15. Out of the x's, they have at the most x to the fourth in common. They have 4 x's in common, so we'll bring that out. And then for the y's, they have at most y to the second in common. Alright, so if I divide 15x to the fourth y to the second by 15x to the fourth y to the second, basically what happens is everything is going to cancel out to 1. And so I do need to write that 1. You can't just omit it this time because we do need that binomial. So if I divide 45 by 15, I'm going to get 3. X to the fifth divided by x to the fourth is going to be x. And y to the fourth divided by y to the second is y to the second. Now, why is it that we had to write the 1 here, but we didn't have to write the 1's here? Well, I didn't have to write a 1 here because I still had a term left over when I did the division. Yes, the 6's canceled out to 1 and the x's canceled out to 1, but I had a y to the second left over, so 1 times y to the second is just y to the second. Here, however, everything canceled out to 1, and since everything went away, I need to show that everything went to 1. So if everything cancels out, make sure you write that 1. But if you still have terms left when stuff goes to 1, you don't have to write it. Alright, factoring out a common binomial factor. We're going to use this in our next technique, so you need to understand what's going on. Here we factored out a monomial factor, which means just one term. But if we look here, what we have is we have a group plus another group, or basically a term plus another term. So if I look at these two terms, I notice that I have an m plus 2 group in common with each one of these terms, because this whole thing, it's a binomial plus a binomial. So in these two terms, I have an m plus 2 group in common. So just like with the monomial factor, this time I'm going to factor out a binomial factor that's in common, which is going to be m plus 2. Now, remember, you're making a multiplication problem, so I know I'm going to need another set of parentheses. So watch, if I divide this term by m plus 2, that's going to go away, leaving me with n to the third. If I divide this term by m plus 2, that's going to go to 1, leaving me with a plus 4. And that's how you factor out a common binomial factor. And like I said, we are going to use this in the next technique, so make sure you understand what's going on. So over here to the right, we're going to factor out a y minus 3. And when we do that, we're going to have y minus 5 left over. Alright, so factor by grouping. When you factor by grouping, you need to have 4 terms. So when you see 4 terms, you need to think 2 things. Number 1, is there anything in common with all 4 terms? And then number 2, if there's not anything in common, then I need to factor by grouping. So when you look at a problem, the first thing you need to look for is there a greatest common factor? And if there is, you're going to factor it out. If there's not a greatest common factor and you see 4 terms, then you should automatically think factor by grouping. Step number 1 says to group terms that are similar by using parentheses. I rarely will rearrange these. So what I tend to do for step number 1 is I just group the first 2 together and group the last 2 together. And notice I included this sign with this second group, and there is a reason for that. Step number 2, factor out the greatest common factor for both parentheses. So we know how to do that. That was our first technique. So in this group, there is an a in common, so I'm going to factor it out front. So if I factor an a out of each one of these 2 terms, I'll have a b plus 3 left over. Now in this second group, I need to pay attention to my signs. So I know that there is a c in common, and I need this group to be left over to be exactly the same as this one, and I'll explain that in just a minute. So I need to factor out this common plus sign. So instead of factoring out just a c, you need to factor out a plus c. And when I do that, I'm going to have b plus 3 left over. Now, we factored out the monomial greatest common factor. Now what we're going to do is factor out the binomial greatest common factor. So we're going to factor out a b plus 3. And when we do that, we'll have a plus c left over. Alright, so let's try this one more time. First thing we're going to do is look for anything that's in common. And I do not see anything in common with all 4 terms. These 2 terms do not have an x. This term doesn't have a y. These 2 terms you can't factor out a 3. So there's nothing in common with all 4 of these. So again, what I'm going to do is I'm going to group the first 2 and group the last 2, including the sign. So out of this first group, we have an x squared in common. We have a monomial factor of x squared in common. So when I factor that out, I'm going to have y plus 4. Now, here I see that I have a 3 that I can bring out of the 3 and the 12, and I also see a y that's in common, so I'm going to bring out a 3y, but I got to bring out a sign. And if I kind of know what's coming, I kind of know that I need a y plus 4 over here. So in order to get the pluses, the positives, I know that I need to factor out that negative sign. So we're going to factor out a negative 3y. And so when I do that, I'm going to have a positive y and a positive 4. So if you haven't noticed a pattern, step number 3 says when you factor out that monomial factor, what's left in the parentheses should be identical. So every time you notice that my binomial factor is identical, and the reason being is I need this binomial factor to be identical so that I can factor it out in that last step. So you need to make sure the signs and everything are the same. And so your factorization is you're going to factor out that common binomial, y plus 4, and then when you factor a y plus 4 out of here, you're going to get x squared. And when you factor out a y plus 4 here, you're going to get a negative 3y. Alright, so let's look at the problem on the right-hand side. This problem is very, very tricky. So let's go ahead and try to factor it the way we would normally factor and see what happens. In the first group, you notice there's nothing in common, so that's not good. So you would factor out, and the only thing you can factor out is a 1. So you have 2a squared minus 3bc. And in the second group, the only thing that's in common is an a, and we can factor out a negative if we want to. But even still, you're going to have 2b plus 3c. And so you can see that your 2 groups are not the same. So what we need to do is what I said that I rarely do, and that is rearrange the original problem. So I think when I rearrange the original problem, what I'm going to do is I'm going to put it in descending order. So we'll have 2a squared. I'm going to basically group the 2's together and write them in descending order. And then I'm also going to do the 3, so I'm going to have a positive 3ac minus 3bc. And notice I did put them in descending order for the 2's. The a's, remember you exhaust your a's and then go to the b. And then the same thing for the 3's. I have the a that comes first and then the b. Okay, so now let's look and see what's in common. For the first 2, there is a 2a in common, and when I factor that out, I'm going to have a minus b. Alright, so in the second 2, there is a 3c, and I'm going to bring out a plus because it looks like the signs are the way I need them, so I'm going to bring out a plus 3c. And when I do that, I'm going to have a minus b left over. Now I have my identical group that I'm going to factor out, and when I do that, I'm going to have 2a plus 3c left over. So sometimes, not always, but sometimes you will have to play around with the original problem just to get your 2 identical binomials. But that should happen every time when you factor by grouping. Alright, so let's try the problems on page 150. And if you have any troubles, bring them to class and we'll do them in class.